There, and welcome to the first installment of the exciting series A Dinosaur Does Docker. We've all heard a lot about this thing called Docker, so I decided just to see what it was all made of and what I could learn in just a couple of hours. I've got an Ubuntu VM here on my Mac. Linux seems to be the most common Docker OS, so here we go. You guys have all seen what Docker is and does, but it's at a very high level. You take a physical box, you have an OS on it. In this case, I've got a MacBook Air running a Linux in a VMware Fusion VM. On top of that, you put the Docker image engine. This layer is what gives us our portability. So if that Docker engine lives on another machine of a different OS type, the translation is all handled between the clients and the engine here. There's a lot of good documentation out on docker.com. You can get downloads from hub.docker.com. We'll go through that a little bit. So I've got a couple little terminal windows fired up here so we can kind of see what's going on with this installation. So the first thing you have to do is get the Docker bits. To do that, like I said, there's a lot of documentation on the website. You use a wget command that is going to allow you to do that. This is going to tell me here, hey, you've already got Docker installed. If you want to upgrade, continue. If not, you want to drop out of this. So I'm just going to drop out of it. But you can see here that I've got Docker installed. It'll tell you the versions, the dates they were released. You've got a client and a server. Obviously, in this case, I'm going to have the client and the server on the same machine. In a larger enterprise, that would be spread out. We have multiple engines and multiple clients and multiple servers. To show a listing of the images that you have available to you is a simple command, Docker images, and it just shows you the ones that you have downloaded on your machine. Just like most things in the computer world, you've got access to a hello world command set or sample, so you can just do a Docker run hello world. That is going to just validate that you've got everything kind of installed right, so that you've got clients talking to daemons, talking to servers, and you can see all that here. If I did not have that image, you saw how quickly that ran, and I can do this real quick. We can remove hello world from my machine. Gone. So you can see here that there's no more hello world. So if you do that Docker run again, it's not going to find it local. It's going to go out and look, and he's going to pull it down and run it. Now the beauty of the hello world is obviously it's very, very small. It's only it's less than a megabyte. You can see also the sizes of some of these other samples. We'll look at a few of them, but like a MySQL instance is less than 300 megabytes. Ubuntu Linux is less than 200. So extremely small, but that's what gives the Docker images or containers their speed and agility, because they're so small, so they boot up almost instantaneously. So there's several basic Docker commands, but like there's a Docker PS that shows you what's running, if anything's running. There's the Docker images. There's the Docker run, which you saw with the hello world. And there's also a pull command where you can Docker pull, and you can go ahead and pull an image before you want to run it. So if you want to stage it for a software load or whatever you're going to do, if you want to pull it down, you can go ahead and grab that. There's a search. Obviously, there's a lot of most people are going to use the GUI on the web with Docker Hub, but you can also search from here. So I can say like a Docker search for something like Ruby. It's going to go out there and see how many different versions of Ruby. And I didn't catch, I'm not sure how many there are, but obviously there's a lot. So you'll want to know what you're going to do for some of these. But there's a basic one. That's where most people are going to start. But it depends on what you're going to want. So that's kind of the really, really basics of it. If I wanted to do just a normal Linux bash, a shell command on that Ubuntu image I've got, it's pretty simple, where I just do a Docker run. I'm going to connect. I'm going to fire up this Ubuntu, and I'm going to run the command that I'm going to run is bash. So now here I am inside of a Linux VM, Ubuntu, running a Linux container of Ubuntu. So I've got a container ID and things like that. If I come back over here into Docker PS, you can see that it gives you some information about what images or containers are currently running. In this case, I've got a container ID for this image. It tells you the command that's running. It tells you how long it's been up and what's going on with it. There's already a Tomcat image running. I'm going to kill it. That was something I was playing with earlier. So I can just say docker kill, and you can either give it the container ID or this handy dandy funny name, I'll call it. So they get all the names, all the containers, distinct container ID and name that you can use when you're working on your containers and management of the running containers. So now you can see that bash is running. The key thing on these images and containers, obviously, is that they are up and down extremely quickly, but that also means there's no persistence built into these. So when I exit that guy, he's gone. He's not running. He's just dead. So if I wanted to install some items into my my container, if you will, I can come in here. And so apt-get is the package manager for Ubuntu. So I'm just going to do an apt-get update, so it goes and pulls down the current packages that are available inside Ubuntu. It just takes us a second to run. Obviously, it's dependent on machine speed and network connection. So now that I've got updated package list, I can install something like just a command line calculator, wcalc. Let's look here real quick before I do this. You can see that which wcalc, it's not there. So if I do doesn't know what that is. So if I do an apt-get and say go install this for me, it's going to go look, see what any dependencies I need. It's going to take up a couple of megs of space. It's going to go grab it and pull it down. So now I can wcalc, and it's just asking for 5 times 6 is 30. So basic calculator. But keeping in mind that this is all non-persistent, it is there now while it's running. wcalc's available, but if I exit and run that exact same command to connect exactly to the same image of Ubuntu, wcalc is gone. It doesn't exist. So that's the main thing to keep in mind when you're dealing with this, is that developers are going to pull down templates, if you will. They're going to monkey with it, and they're going to save their own. And in a later session of this, I'll show you how we're going to save our own. Back to something like a Tomcat. So this is not a bash command inside of a Linux machine. It's an actual running application. So if I do docker run Tomcat, it's going to run Tomcat and then drop right back out. It's not going to stay persistent. So I've got nothing to really go manage here. You can see where it's not giving me any data on a port or anything like that, because it's just running that command. So what I want to do is I want to run something like that. This is what you would do with a MySQL or a Tomcat, or anything that's going to run, not necessarily forever, but you want it to keep running. I'm going to say docker run. You give it a persistence and say, I want you to keep running Tomcat, and that gives you an ID. So now the little difference is here I've got the container ID. Here's what it's running. Here's the command it's running inside of that container, and it also gives me the port number for my my web server. So now I've got a Tomcat web server running inside a container that I can go connect to here. Localhost. What was that one? It was 32770. So I do 32770, and here I am connecting to that Tomcat server that's running inside of that container. So all this is local. You can see I'm not leaving the machine to go look at these documentation and things like that. Obviously, I'm not a web developer or a application manager here, so I don't really know what more I would do here for me personally. But I can also, now that I've got that up and running, I can connect to that guy just like I did to the other, but it's a little bit different because it's a persistent running container. So I would do something like this, where I would connect to, crap, I need the name, Docker PS. So hi Lalandi. So I can just copy that and say I want to connect to this guy and give me a bash command there. So now I'm physically on that running web server at the underlying Linux level, right? So I can go into web apps and see the docs. So I can see all those documentation. So like index.html is exactly what I was looking at here from a documentation standpoint. So this is the same file. So I could go modify these files and things like that, but if I don't create a persistent image, this is going to go away. Same as that wcalc image did with the bash example. So that's kind of the basics of downloading a container, running a container, and seeing that it's, like I said, non-persistent. And how would you make something persistent? I can close this web browser. I'm still inside of that that Tomcat image. Now I'm back out. It's still running. If I say docker kill, that guy should still be in my. It's now gone. And so now all of the there's nothing running. There's nothing but the machine that I've got with the images that are available. So that's, like I said, that's kind of the basics of how you download the Docker image on the Linux box, how you run some sample, download and run some sample containers, and then how you interact a little bit with the containers. And in the next session, I'm going to attempt to show you how to make some changes inside that container and then save and utilize that container with the changes that you would want to do. So if you were a developer or doing real work other than just playing around with this, how you would save it and make it persistent. So thank you, and stay tuned for A Dinosaur Does Docker version part 2. Bye-bye.